Okay, welcome back to part 4. Now, I hope these practicals are clear. I'm afraid I've got my daughter at home and I'm running in and out helping her, so I'm struggling to just keep my brain in one place, but I'm hoping it's clear and I'm hoping you're following along. Okay, so now we're going to move on to the final part, control 4. And I think with all of these practicals, just do what you can in the time. You know, if you're falling behind, just watch the video. But I really wanted to give you something very practical and something that, you know, you're using real data. So I hope this is useful. And once you get good, you can actually do these quite quickly. I could probably do this whole practical in 10 minutes, even less, maybe 5 minutes if I'm not talking. So once again, cut and paste, because we're just going to load in the variables. Now we're going to analyze the longer term component. Let's run it and bring in the kind of variables we want. Okay, now what I'm going to do here is I'm actually going to work with annual means rather than monthly data. I think it's just, when you're looking at trends, it's a bit more easier to work with kind of annual files. So what we're going to do is we're going to do a loop. So I'm going to do a loop, and every loop has starting with the word for, 1897 to 2019, and then end. And hopefully, if you haven't used a loop before, just look it up. But hopefully when you run this, you can see all that happens is each time this code loops through, the first time it loops through YR is 1897, then it runs whatever code is in between these two lines, then it goes back and it's 1898, runs that. So a loop is just a nice way of running the same bit of code multiple times. Now, I'm just going to do a little trick as well. I'm just going to put in a counter. If this loop started at 1, I wouldn't bother with a counter, but because it starts on a big number, I'm just going to put a counter there. And this counter is just going to count up each time. And what I'm going to do is I'm going to create a variable called YA, which is just the kind of annual year, and I'm just going to put in YR each time. And the counter, the first time, this will be 1, that'll be 1897. The next time, the counter will be 2, that'll be 1899. And you can see that this has just stepped up and created a matrices with the year in. So a loop is just a nice handy way of doing that. Now what we're going to do is we're going to use the find function. I use the find function more than any other function in MATLAB, but I'm going to find the year month that is greater than or equal to my year, so 1897, and the year month that is less than my year plus 1. So the first time this loops through, it will find the data between 1897 and 1898. Next time will be 1898 to 1899, and that will just return the row numbers. And there should be 12 each time. I mean, you could click this up and run it, and you should see J should always be 12 each time because it's finding 12, and it should always be 12 later, which you can see it is. So now I'm going to say relative mean sea level, raw mean sea level. I'm going to put an A on the end for annual. It's just going to be the nan mean of the raw mean sea level, but just rows J. So what this does is it just calculates a mean of each of those relative mean sea level. It's just going to calculate, so now this is only 123 long. So each of these values is just a mean of the 12 months in each given year. So that's just a nice way that we've kind of used a loop to calculate annual means. And now we can plot this and fit a trend. So what I'm going to do to start with is just calculate a trend for the whole period and plot that. Okay, now to calculate a trend, we've already done it before in control 1. We can use the poly fit, but just before we do that, I'm just going to get rid of the NANs. It's just easier to fit trends without them rather than. So I'm just going to say I is find. Again, I will give me the row numbers. So again, you can see I'm using find. Find is nan, relative mean sea level A, and then relative mean sea level A, row I, I'm just going to remove. Now I need to do the same for the year as well. So I'm just going to remove anything and you can see it will make it shorter. There's 123, but if there is anything with an NAN, it will remove it. So actually, let's check it now. 100. So we have removed a few. We've removed 5 years when there's no data, but it just makes this much easier to fit linear trends. So first of all, we're going to fit a linear trend to the whole data length, and we are going to do the trend line T1. If you want, we can calculate the error matrix as well to see if that line is statistically significant or not. So we use the polyfit to the yi by the relative mean sea level A and 1. And then I'm just going to fit a line, let's call it L1, mean sea level, using the polyval, because I want to plot the, I don't just want the fit, I want to plot it as well. T1 YA, so let's run that. So now what we really want to look at is T1. So this line, so the trend is 1.65 millimeters per year. So let's plot that. I'm just going to borrow some code here like I've done before and just make sure I edit it. Plot linear trend with data. Okay, I'm going to plot 4 plots here. So let's make that A1. Let's make this 4. So I'm going to plot YA. Let's plot that as red, and I'm going to plot the relative mean sea level A, and then on top of that in magma I'm going to plot the line L1 mean sea level. So this is now we can give that a title A. This is something like the linear trend, or let's just call it mean sea level rise for, okay, well, yeah, for the period 1897 to 2019. But what I want to do is actually add the trend to the title. So I can use square brackets, and like I did for the file name, I can actually use this function called num to string. I can change the number to a string, and I'm going to do 2 1 row 1 column 1, that number there, and I'm going to put it to 3 decimal places, and then at the end I'm going to put the units millimeters per year. Let's just check I've coded that correctly. Okay, now it's got a problem here. That's because I need a capital L. Okay, so there you can see, let's put a space just to make sure it looks nice. So now you can see I've actually written the trend into the line there. So the trend for the whole period is 1.68. Now what's really nice now is we can really easily edit this code. Now we can calculate the trends for different periods. And we're going to do 1900 to 1990. And let's just go to Google. And what we can do is, I've put the link in the step-by-step guide, but we can put the IPCC special report on cryosphere and the ocean. And we can look at the sea level rise chapter. My internet's a bit slow. We can look at the summary here, and you can see they specify 3 different periods, 1901 to 1990. I think I made a mistake actually in the step-by-step. I put that 1900, but 1 year shouldn't make a difference. 1970 to 2015, and we can compare and see how these trends just at Fremantle compare with the global mean. So what I'm going to do is I'm actually going to cut and paste all of this code. But now, rather than fitting a trend to the whole period, we could use the find function to just find a particular period. So we could find YA that is greater than 1990, greater than or equal to, sorry, 1900 or 1901. I don't think it's going to make too much difference. And YA that is less than or equal to 1990. And then here we can fit the trend just to I, just to the I component. And here, and let's just make sure we do this generically. So let's call that I2, just to be consistent, I2, and then we can fit this just to I, just to the I2 component. Okay, so here I'm just going to plot the rows between that period. So that's why we add in that. And here I'm going to make this line 2. You'll have lots of variables here. It's going to get a bit confusing. So, but now we can put that 1900 to 1990, change these to 2, just always try and be consistent. Okay, and let's run that. Oh, I've set up a new figure. I can actually take out that new figure line because I actually want to plot it on the other figure. I think my MATLAB's having a bit of a problem. Let's run everything again. Oh, I want to plot this on plot 2. Okay, so there you can see, rather than fitting the whole period, I've just fitted the period from 1900, and now you can see the trend is a little bit smaller. It's 1.49. Okay, now what's really nice is we can actually do this pretty quickly now, but we can now pick a different period. And again, let's pick this period so it coincides exactly with the special report. So let's go from 1970 to 2015. So we can change this to 1970, that one to 2015. Now this will get a bit confusing with all the numbers, but let's make that I3, just so we don't overwrite. Make these I3, I3. This will be line 3, line 3. This should be T3, T3. So again, I should probably go back and change that to 2, just so they don't overwrite. I'm just going to run the whole thing again. Oh, remember I'm having to change this to 3. There you go. So now you can see the trend is a bit bigger. So sea levels rose faster over the latter period compared to the early period. And then let's just do one final period, which is the same as satellite altimetry. So the start of satellite altimetry was in 1993. So we can change this to 1993, change that to 93, leave that as 2005. So this will be 4 now, 4, 4, 4, 4. Oh, I need to fit the trend to the right period, 4, 4, 4. So again, just make sure you've got the right 3. I'm rushing this a bit, that's why I'm making mistakes, but you can see how you can go back and just change the mistakes quite quickly. And this will be D now. So this is now 1993 to 2015. This should be D4, T4. That should be T3, 1970 to 2015. This will be C, 3. Sorry, I'm rushing, but you can see how, just check that everything is right. Something's not quite right with my bottom plot, L4, but that's because I haven't plotted L4 here. I forgot. Okay, so now you can see we've got trends of 1.6, 1.49, 2.3, and 3.67. But if we start with a 1.49, actually that coincides with 1.4 very well. Then we have a trend of 2.73, that coincides with the 2 millimeters. You can see levels faster, and then the final period is 3.6. Ours is a bit faster, but that could be due to the considerable interactive variability. But you can see that certainly over the 20th century, the trend in Australia is comparing very, very well with the global mean, and we haven't removed vertical land movements as well. So you can see they agree quite well. And then the final thing we can do is, rather than fitting a linear trend, we could actually fit a quadratic trend. And I'll go back and pick up this bit of code. So now we could fit a quadratic trend. So that tells us that sea level is rising, but it doesn't tell us if the rate is getting faster. Now this is really easy because all we do here is change this to a 2. But let's put a Q in there, just so there's no confusion. So Q. So this is now a quadratic trend. So I'm just going to have one subplot just to make it easier. Now this will be the mean sea level rise acceleration. So you can see that sea levels are accelerating. Probably if we make this bigger, it'll be easier to see, but there is a very slight, let me just check that I've plotted the right thing, LQ. Yep, I've got a 2 there. Oh no, you see, I'm still doing the linear fit there. So you can see that line does bend up slightly, which shows there is an acceleration, so that rate of rise is getting faster. The signal is very, very small, it's 0.004. So it is small, but there is an acceleration. So just finally, the last thing I always do is create a README file. I always call it A, so it's the top. Get into really good practice of doing this. Now rather than writing this, I'm just going to cut and paste it in from something else that I've done. So again, I just have control 1, control 2, control 3, what they do. And again, the nice thing about this is if I close this down, bring up my README, run it, it opens everything up for me and I can just run through all of the stages again. Now the really nice thing I can do is try this for a different site. So I can go now back to the permanent service for mean sea level. Permanent service for mean sea level. And I can pick another tide gauge site here. So for example, I can go back to the data set here, and in fact, actually, I find it easier to go to the map. So you can click on the map, and let's go to Broome as an example here. Okay, now if I scroll along, there's the monthly data. So I can save this into my data folder. Practical2, data, and you can see it's got the same format, but it's just a different number. So it's 1159. So now I should be able to change this 1159 and run it. And you can see I've run it instantly. And you can see here the trend looks to be a lot bigger, but now I can go into all of these and just do 59. And you can see the seasonal cycle is quite different here. It peaks in April, not June. It peaks in August, and that's because it's further north. So, and again, you could see I could done. So actually, I could now download any site, all 1,500 sites, and run it through this. So you can see that it's taken me a good hour to code this, but now I can run this for almost any site. Well, I can run this for any site around the world. There might well be something in my code I have to change. But it should be 99% of the way there. So yeah, well done on getting through Practical2. I hope you've enjoyed it. I really wanted to give you real hands-on experience, and this is the sort of thing I do on a day-to-day basis. And if you can really persist and get good at MATLAB, I promise you it will really help you in your career, whether you stay in science or whether you work in a consultancy, whatever you do. Having these skills is really, really useful. And actually, we haven't used many functions. Although we've written a lot of code, we've only really used the load function, we've used plotting, polyval, polyfit, but we haven't, you know, the coding here is actually relatively simple, and we've been able to achieve an enormous amount. Okay, thank you.